GPT 5.6 might be stronger on benchmarks and still be worse for your real codebase. That sounds strange, but it is one of the most important ideas in AI coding. Benchmarks are controlled. Real projects are messy. Benchmarks reward solving a task. Real development rewards solving the right task without breaking anything else. That distinction matters because third-party numbers are already mixed. Artificial analysis says GPT 5.6 Sol Max lands just 1 point below Claude Fable 5 Max in its intelligence index, 59 versus 60, while costing roughly 1/3 as much per task in that evaluation. But Vals AI's SWE-bench verified page lists Claude Fable 5 at 95%, with Claude Opus 4.8 following at 88.6%. In other words, depending on which benchmark you look at, the story changes. That difference is huge. A model can look incredible on a coding benchmark because it is aggressive, fast, and good at finding patterns. But inside a real repo, that same aggression can be a problem. It may rewrite too much. It may ignore local conventions. It may patch the symptom instead of the cause. It may add a new helper when the project already has one. It may make the test pass while damaging the design. This is where Claude Fable 5 could still matter. If Fable 5 is better at careful planning, constraint following, and long context reasoning, it may produce safer changes even if another model looks more powerful in benchmark headlines. For real developers, safer often beats flashier. Imagine you ask an AI model to fix a bug in a billing system. Model 1 quickly edits 5 files and makes the error disappear. Model 2 reads more, asks one clarifying question, edits 1 file, and explains the trade-off. Which one do you want? Probably the second one. The best coding assistant is not the one that writes the most code. It is the one that respects the code that already exists. That is why real code-based testing should include these questions. Did the model inspect before editing? Did it understand project patterns? Was the diff minimal? Did it add tests? Did it avoid unnecessary abstractions? Did it explain uncertainty? Did it create work for the human reviewer or remove work? This is also why vibe-based reviews can be misleading. A model can feel amazing because it responds quickly and confidently. But confidence is not correctness. In fact, the most dangerous AI coding model is the one that is wrong in a polished way. So when comparing GPT 5.6 and Fable 5, do not just ask which one wins terminal bench or SWE-bench. Ask which one behaves better in your repo. Run the same task on both. Use a real bug, use a real feature, use a real test failure. Then compare the final diff. If GPT 5.6 produces a cleaner, tested, smaller change, use it. If Fable 5 produces a more careful plan and fewer weird assumptions, use it. But do not blindly trust the model with the bigger launch. Real codebases punish overconfidence. And in software engineering, the best model is not the loudest one. It is the one that changes less and fixes more. There is another reason real codebases are harder than benchmarks: history. Every serious project has history. Old decisions, weird helper functions, naming conventions that only make sense inside the team, tests that encode business rules, workarounds that exist because of some production incident from 2 years ago. An AI model does not automatically know that history, so a powerful model can make a change that looks technically clean but is culturally wrong for the project. That is why I like to test AI coding models with constraints, not just tasks. Do not say, "Fix this bug." Say, "Fix this bug with the smallest diff." Do not introduce a new dependency. Follow the existing error handling pattern. Add one regression test. Explain what you intentionally did not change. Those instructions expose the difference between a code generator and a coding assistant. A code generator produces an answer. A coding assistant respects the environment. If GPT 5.6 handles those constraints better, it wins. If Fable 5 handles them better, it wins. The brand does not matter. Another test is the rollback test. If you had to undo the model's work, how painful would it be? A good AI patch is easy to review and easy to revert. A bad AI patch touches everything, creates new abstractions, and forces the human to untangle the model's imagination. This is why smarter can sometimes feel worse. The model has enough ability to build a complex solution when a boring fix would have been better. Real engineering rewards boring correctness. So my advice is this: when testing GPT 5.6 and Fable 5, do not ask which one can impress you. Ask which one can behave. The model that behaves better inside your constraints is the model you should use. There is also a human factor. Some models make developers feel powerful but careless. They generate so much code so quickly that the developer stops reviewing with full attention. That is dangerous. The best model should make you faster without making you lazy. It should keep you in the loop. It should expose assumptions. It should make its changes understandable. It should help you reason, not just produce. This is why explanation quality matters. After a patch, ask the model, "What changed? Why was this the smallest fix? What alternative did you reject? What test proves this works? What could still be wrong? A strong real codebase model should answer those questions clearly. If it cannot explain its patch, do not trust the patch. This may be where Fable 5 has an advantage in some workflows. It may produce better reasoning around the code, but if GPT-5.6 produces better verified patches, it may still win execution. Again, the answer is role-based. Use the model that plans best for planning. Use the model that patches best for patching. Use the model that explains best for review. Real codebases do not need one hero model. They need disciplined help at every step. The safest conclusion is not GPT 5.6 loses or Fable 5 wins. The safest conclusion is GPT 5.6 looks extremely competitive on cost and agent-style work, while Fable 5 still has very strong evidence in software engineering-style evaluations and long-horizon coding claims. That is why your repo matters more than a single chart.